Hi, everyone. My name is Heather Whyte, and I am a software engineer at a fintech company here in London called Lambay. I've been a software engineer um, almost 3 years now, but I started myself originally teaching myself to code from previously coming from a finance and an HR background, actually. And so I did programs similar to codebar to help myself learn and to get practice at this before I actually made the transition into becoming a professional software developer. And so I was very excited to get involved with codebar, both occasionally as a coach, and now it's my first time as part of a monthly to get to share some knowledge with all of y'all. Um, so yeah, I'm doing a talk about introduction to microservices because this is something that when I was just starting out, I'd finished a coding boot camp and I was looking to apply to all these jobs, and a lot of the ones that I found really interesting, they would talk all about the fact that they have microservices. I saw this word come up again and again, and I had no idea what that was or what that meant or how I could learn that so that I could get these jobs. And now I work with them all the time. And so it was definitely something that intimidated me, and I didn't find a lot of easy to access resources. So hopefully this will give all of you an introduction to what they are and how you can use them, and how as a new developer you can start to dip your feet in the water for this. So what are microservices? If you haven't heard of them before, basically they are a software architectural style, or it's a way that you can design your software application. And I know that, yes, you guys are, I assume most of the people over here are like learning how to code, junior developers. And so if you're a new developer, why do you even need to know about the architecture, these big enterprise systems or big cool companies that, that's what the senior developers are there to do, or the CTOs or things like that. But actually, in reality, there's a lot of stuff that is helpful to know as a junior, because understanding what architecture is, it helps you understand just the overall big picture design and organization of the software systems. So a good architecture can help the system be faster, more performant, make it easier to add new features in the future. And while you may not be designing, whole systems in your first job, you will be adding to them. You'll be creating those features. So it's really helpful to understand how that works, understand some of the terminology that might be thrown around at places that you might work. And even better, you can start to understand why those decisions are being made and why things are being done that way. So you can start to see how the code that you're working on, the code that you're building, fits into the bigger picture. Plus, you might not be an architect now. That doesn't mean you couldn't be in the future. It's always good to get started. So just going to talk, before we get really deep into what microservices are, I'm just going to mention quickly a couple of other software architecture styles that terms you might come across, or also things you actually might have even done before. So the first one is a very traditional layered architecture. So this is actually one of the most common designs. I'm not sure how many of you work with Java. I know a lot of you are more JavaScript front end, but a layered architecture is just having the data enter through the UI and then work its way down, such as an MVC or model view controller. So this is, you get the information from the user, and then it talks to the application, and then it goes into the database and then goes straight back up. And every bit of data and every bit of the application is all sort of in these large layers. And so sometimes that's called a monolith as well. It works really well for if you're building your own project, but if that entire application, runs 1,000-person bank, then it's probably going to be pretty monolithic. The next one that you have is called event-driven architecture. So this one is, rather than being focused on the data and the layers itself, it focuses the most on actions that might happen. So it organizes itself around waiting for components to change state to trigger major action. So waiting for a purchase to be made to trigger another action. And those use things like events and messaging queues, such as like RabbitMQ or Kafka, if you've seen those. And then there's a very fancy sounding one called space-based architecture, which I've never actually used myself. But this is for like those large companies that get huge unpredictable spikes in traffic. So you can use space-based architecture to handle this by replacing any sort of central database and instead having lots of in-memory objects. So you don't have 10 million database calls all at the same second that are happening. Yeah, so these are some of the traditional ones. And last but definitely not least is microservices, which is a form of service-oriented architecture. So it's all tailored around actually the actions that you have. One of my favorite ways to explain this is sort of thinking about it as a soccer team or as a football team. And each microservice is like a player. So each different microservice or player has its own roles or specializations within the team, but they're also communicating with each other in order to get things done. And in football, that's done by shouting or running specific plays. But in a microservice, that's done by making REST HTTP calls or by sending messages using things like RabbitMQ or Kafka. So it uses a little bit of that event-driven architecture too sometimes. And well, all of these different players or services are coming together to make the application work. If, say, one player is injured or is, fails or is taken out, the whole system doesn't come crashing to a halt, unlike that is possible with a monolith. So what happens is, okay, that piece is out, but everything else is still working. And then so you can fix that one service, get it back up, and then your entire application isn't coming crashing to the ground, which is always a good thing, having more reliability. Yeah, and so the reason because is these are all independent pieces, they're independent players, they're independent services, and really, really, it is important that you have this sort of like level of independence for each of your services. You want to make sure that they're able to support themselves, because that is where you get the real benefits from microservices. So in short, outside of the analogy realm, microservices are a collection of services that, first of all, each have their own business purpose. So there's a reason that you're separating them into different services. They are loosely coupled. So what that means is, well, they do interact with one another because they each have their own business purpose. They don't rely on the other services in order to be running, in order to be up, in order to be accessed. And this, again, this level of independence really helps create that resilience within the system. They're independently deployable. So if you're making changes to one microservice, and then you can deploy that, you don't have to wait for the entire rest of the system to fit together with that. And also each microservice owns its own data. So we'll have a separate database for that service that it owns and it controls, and that other services can ask for that data, but they can't access it directly. These are some of the core components about what makes a microservice architecture exist, and what makes something a microservice. Yeah. So here is a very, very super simplified version of something, similar to what my company does, which is like banking, investments, and mortgage loans. So especially in terms of mortgage loans, we have, in this example, 6 different microservices that deal with different parts of the business. So deal with loans, the borrowers, the physical properties, the interest, the banks, the emails. And each of them has their own separate database that they're solely responsible for. And so if the loan service wants information from the interest service, it has to have a connection, usually through API calls, occasionally through event messaging, that will talk to these 2 different services. And it can be in any sort of configuration that they'll talk to each other in order to get what they need. But this was the way that they're coordinating with each other while still being different. It can be similar to, if any of you have ever used any sort of third-party API to get data or information. Like if you've used IBM Watson, or if you use a Twitter app, you're connecting to another application that exists, except in this instance, one organization owns all of the different applications and it just talks to each other, but they're treated as independent units. Yeah, so there's lots and lots and lots and lots of benefits to microservices, which is why they're really popular. So some of the ones I wanted to highlight, and we kind of touched on already, is it's a lot easier to build and maintain those systems because they're broken down into separate chunks. You can have improved productivity, because as soon as you make a change to your one microservice, you can push it out, oftentimes using continuous integration and continuous deployment, or CI/CD, if you've heard that before, because it doesn't need to be concerned about the entirety of all the code base of your entire organization. It just needs to work for this microservice. There's improved reusability as well, because it separates out by business logic what code you need to do, and other services can access that, but without having to have all the same complexity contained within that service. You can just get the answer you want. You don't need to know all like the math and physics behind it. Again, yeah, it's more maintainable. If something breaks, then you have isolated failure rather than one little bug taking out the entire system, which, especially as a new developer, is also nice, because it's a little bit less terrifying for you to first deploy something into a new environment. And it also allows something I think is quite cool, is for technological diversity. So what I mean by that is, usually you have an application that's written in usually about one or two languages, maybe a front-end language, back-end language. With JavaScript, sometimes that's just one language overall. But with microservices, if you have something that is best done for using Python and a different type of application that would be best written in Java and something else in JavaScript, you can just build them in whatever language or with whatever tools work best for that situation. And then they're still communicating over HTTP, so they're communicating with the same language, but it allows you to work and develop in different ways. It's also really cool for trying out new things. So if you want to try out a different technology or language, you can try it on a new microservice or a different microservice, and without having to break it out or test run it on your entire application. Yeah, so these are just a couple of the cool things about microservices. That being said, they are not good for everything. There are some downsides to microservices, and they're definitely not something that you need for every application, and they're not the best solution for every application. So if you, for instance, are making a side project for a Twitter bot that, posts all the best soccer scores that are happening, it probably doesn't need to be a microservice environment. Like, one application is probably enough for that. Not a single one of my side projects has ever used microservices, because it would honestly probably be overkill. And if you do try and create a microservice environment, but you don't follow all the principles that we were talking about before about making them independent, so whether that's independently deployable, or you have 20 different microservices but they all use the same database, then that can turn into something that's called a distributed monolith. So pretty much you just get all of the overhead of microservices without any of the benefits, which obviously not ideal, not a thing you want to do. So it is something, you have to see if it's right for this thing you're trying to build and the thing you're trying to do. And really, that's like one of the biggest principles of architecture in general. There's good practices and there's and there's bad practices, kind of, but also the best and most important thing is understanding what are you trying to build right now and what makes sense for that situation. Because there's never anything that's like all the time, 100% of the time, this is the thing you should always do. And the last thing is about not creating what are called nano services. So nano services are like, if they're a little bit too micro, if they're too tiny, And they think that they're all grown up kind of microservices, but they don't really do anything. If they constantly are interacting with 7 other services just to do its basic job, and relies on data from elsewhere, it just is creating extra overhead that you don't really need. And having that sort of like nano services is what's one of the bad practices or anti-patterns. It can be a real giant pain to maintain. So, well, the term is microservice is not necessarily that smaller is always better. It's more about cutting it as logically as possible. Yeah. So that's sort of in a nutshell what microservices are, the good, lots of good, and the bad as well, the things to look out for and understand. Um, and so who actually uses microservices? I mean, again, my company does, and we're a startup of sorts. We're about 100 people. We've got about 20, 25 people on our tech team, and we have about right now 50 or so microservices. So it's a nice, so you kind of can conceptualize all the things, but it's not just something that startups use. It's actually got very popular by some of the really, really big companies. So you might, I hope, recognize a lot of these. Uber, Amazon, Netflix. Netflix in particular talks a lot about microservices and was one of the big organizations to push for these to begin with. And they were sharing a lot in their open source. So I really do recommend checking out the Netflix blog to see how they built their microservices. It's quite cool. But these are just a couple names I found on the web of companies talking about how they're using microservices. To give you a sense though, so this is again a simplified version of my works microservices. We have about 50 in reality. But to give you a sense of what some of the big companies look like. So this is Uber, or one of their pictures of Uber at one point in time. All of those dots are like different microservices. And this is from some images of Amazon and Netflix, where like, honestly, I couldn't even count all the dots if I tried. They just have a ridiculous amount. And so not a single person in Netflix knows what all their microservices are, or what they do or how they connect. That's why you have tools for that sort of thing. But it does allow people to make changes and continue to build and continue to innovate on these big sites and make these changes so quickly because they have that sort of separation of power and responsibility within these mega organizations. So yeah, so if you're interested in learning more about microservices, or if you're applying to jobs and you see that they use microservices, first of all, you don't need to have worked with them to get a job there. I learned everything I know about microservices on the job. So just by listening to this talk, you're probably already ahead of me when I was applying for jobs. So good job. But the kind of things that you can look at, the information that would be good to know and understand, is how to make and build and use APIs, especially RESTful interfaces is a really, really big one. Working with databases is usually a pretty big one as well. Relational databases are the most common, but also looking at NoSQL databases or things like Elasticsearch are often used in microservice environments. I mentioned messaging. So that's where you send out an event, the different services will listen to that, and then that will trigger some actions. So it has to do with event-based architecture as well. Some tools include Kafka, RabbitMQ, or SQS, which is simple queue service on Amazon. Understanding also how things work from a deployment standpoint. Microservices tend to go hand in hand with CI/CD, which is continuous integration, and then CD is either continuous delivery or continuous deployment, depending on which organization you are. But understanding how this feeds into being able to constantly deliver and deploy redeploy changes into your services, and how that goes through the build pipeline and contributes to continuous testing. These kind of things fit in very nicely and fit in very well. Not required for microservices, but they often go hand in hand. And then last but not least is containers. So oftentimes these microservices also take advantage of containerized environments. So if you've heard of Docker or ECS, which is Amazon's Elastic Container Service, or Kubernetes, these are all ways of using containers in order to, so container is like an executable like unit of software in which your app code is all packaged into its own independent little library and dependency. And then Kubernetes is a way, and ECS are a way to like manage those in the cloud. Definitely look more to that if you're into DevOps. Don't need to get really into it if you're just doing the code side of it, but it's interesting sort of world to dive into. Yeah, so these are, you don't need, again, to work in a company that is microservices, you don't need to know all of these things, but they're good sort of starting jumping off points in order to sort of get familiar with the type of environment, the words, the lingo, the concepts that you might come across either in these jobs or in interviews for those jobs. Yeah. Yeah, so that is all that I have to say for now about introduction to microservices. I tried to cover a wide spectrum, but in sort of a high level detail, just to not overwhelm too much, because it is one of those things that's very easy to get a hold of once you start doing it. But does anyone have any questions? Cool. Okay.
Right. But yeah, thank you so much, Heather, for your talk. And actually, before I started my job, I didn't know anything about microservices, so this would be great for anyone who's going into the job and things like that. And I love all the memes and things. Yeah, great. Thank you.